Hi students, now we'll be looking at part 3 of the video. So in this video, I'll show you how to draw the diagrams for an ionic compound or a covalent compound. So first thing first, let's check what are the two elements that we are dealing with over here. So we are dealing with sodium and oxygen. So in order to know the number of electrons of these two elements, we have to first determine the number of protons first by looking at the periodic table. So in our periodic table, I know that sodium has 11 protons, while for oxygen it has 8 protons. So that's why I put 11 and 8 over here. So now, next step, we will be required to write out the electronic configuration. So for sodium, it will be 2, 8, 1. For oxygen, it will be 2 and 6. So by looking at the electronic configuration, we'll be able to determine the number of valence electrons. So which number do you look at in order to know how many valence electrons does each element has? So we look at the last number, because the last number represents the number of valence electrons in the valence shell, which is the outermost shell, the electron shell that is furthest away from the nucleus. So this one will be 1 electrons. So it will be 6 valence electrons. So by looking at the number of valence electrons, you'll be able to determine the group number for these two elements. So since sodium has 1 valence electrons, it means that it's in group 1. While for oxygen, it has 6 valence electrons, means it will be in group 6. So by looking at the group number, we'll be able to know whether they are metal or non-metal. So for metal, what group will they belong to? And for non-metal, what group do they belong to? So for metal, they'll be belong to group 1, 2, and 3, while for non-metal is 4, 5, 6, 7. So sodium will be a metal, while for oxygen it will be non-metal. So when the compound involves a metal and non-metal, this means that it's a ionic compound. So for an ionic compound, we need to know how much electrons does each element lose or gain. So for metal, right, how many electrons to lose, and for oxygen, how many electrons to gain. So let's look at sodium. So sodium, right, has an electronic configuration of 2.8.1. So in order to achieve the noble gas configuration of only 8 electrons in the outermost shell, it has to lose 1 electrons. So it has to lose 1 electrons. So for oxygen, in order to have a fully filled valence shell of electrons, it must gain 2 more electrons. So now the question is, after I have determined the number of electrons to lose, gain, or share, now I need to determine the number of atoms needed for each element in order to form this ionic compound. So how do I do it? I can do the cross method. So since I know that sodium lose 1 electrons, while oxygen need to gain 2 electrons, right? To balance out the electrons, you have to find out which the number that you need to multiply in order to make the number of electrons tally. The number of electrons that you lose will be equal to the number of electrons another element gain. So in this case, I need to times 2. Times 2. And after I times 2, it will be equals to 2 electrons. So this means that there will be 2 sodium ions and 1 oxygen ions, which form a chemical formula of Na2O. So these 2 over here represent the number of sodium atoms you need, number of sodium ions you need in order to form this ionic compound. So now we need to draw out the dot and cross diagram. So before you do anything, you need to always do out your legend to tell the marker that cross represents a type of element and dot represents the electrons from another element. This should be sodium. Okay, so since sodium need to lose 1 electrons, its electronic configuration it will be 2.8. So first shell, write sodium first. Sodium. Then the first shell will occupy 2 electrons. Okay, so bear with me. So the first electron shell, it has 2 electrons. So now for the second electron shell, we can fill up to 8 electrons. So after we draw in the electrons, we need to indicate what is the charge of this ion. So this ion will have a positive 1 charge. That's why I draw a square bracket and put a plus charge outside the bracket. So since there are 2 of them, then we have to put a 2 outside. So you have drawn in 2 sodium ions. But in order to make it more representative of the ionic compound, the positively charged ion will be drawn in an alternate manner with oxygen ions oxide. So this means, right, sodium, oxygen, sodium, oxygen, sodium, oxygen, sodium, oxygen. It will be always in this order, whereby the opposite ions are like alternating between each other. As ions of the same charge, they tend to have like repulsive forces against each other. That means they will repel because they have like charge. That's why they repel. So now we'll draw the oxide, which is the oxygen ions. So I draw in the first electron shell first with 2 electrons. Now I need to draw 8 more electrons for the second shell. But a thing to note is that the additional 2 electrons, they came from sodium. That's why you need to draw the cross to represent that these electrons initially came from sodium. Okay, to make the drawing easier for you to see, that's why I use a different color in order to differentiate that these electrons came from sodium. So is there anything that I missed out when I draw this ionic bonding diagram? On the sodium, there's a charge, but on the oxygen, is there a charge? The charge is missing. That's why you need to put in the charge for the oxygen. In this case, it will be 2 minus. So this is how your ionic bonding diagram should look like for sodium oxide. 2 sodium ions and 1 oxide ions. And remember to draw a legend. So you can apply these methods, right, for any types of ionic bonding that you encounter. So first step is to determine the number of electrons for each element using the atomic number. After that, you write down what is the electronic configuration. So this is how we write the electronic configuration. After that, by writing down the electronic configuration, it allows you to see that the number of valence electrons that each element has, which then allows you to determine whether is it metal or non-metal. And after you determine whether is it metal or non-metal, you'll be able to identify whether is this an ionic compound or is it a covalent compound. So thereafter, you need to know how much electrons needed in order to fully fill the valence electron shell. So if for sodium, it has an electronic configuration of 2.8.1. So it's easy for them to like lose 1 electrons. While for oxygen, it's easier to gain 2 more electrons in order to fully fill the valence shell. So this sodium need to lose 1 and oxygen need to gain 2 more electrons. So now the next question will be, how many atoms do I need in order to balance out this ionic compound? So the number of atoms needed in order to form the ionic compound, it will be 2, because you need to have 2 sodium atoms to lose 1 electron each in order to give you 2 sodium plus ions, Na plus. And these 2 electrons that is being lost, right, will go towards oxygen. So for oxygen in this case, right, you just need to times 1 in order to have the same electron distributions as compared to sodium and oxygen. That's why in the end, your chemical formula for sodium oxide will be Na2O. So when you draw the electronic diagram, this one, you have to draw 2 sodium ions with 1 oxygen ions with the respective charge and with the legend to signify that cross represent all the electrons from sodium, while oxygen represents all the electrons from oxygen. So for the electrons being gained from sodium, right, you have to write it down inside the oxygen ions also. So this is how you draw your electronic structure when they ask you to draw a diagram for ionic compound. So now we look at covalent compound. Okay, so let's say I don't know that this one is a covalent compound. So how do I go about thinking that and concluding that this is a covalent compound? First step, same as the previous one, write down the number of protons, which tells you the number of electrons. And in this case, it will allow you to write down the electronic configuration. So for carbon, right, is 2.4, while for oxygen is 2.6. So for the last number in the electronic configuration, it tells you the number of valence electrons that each element has. So carbon has 4 electrons, while oxygen has 6 electrons. So carbon has 4 electrons, 4 valence electrons, and oxygen has 6 valence electrons. So this enables us to determine that carbon is in group 4, while oxygen is in group 6. So group 4 and group 6 element, they are non-metal. So when you have a compound that involves non-metal only, this one will be a covalent compound. And for covalent compound, they will share electrons. So for carbon, how many electrons does it need to fully fill its valence shell? So since it has only 4 valence electrons in the valence shell, it needs 4 more electrons to meet up the maximum number of electrons of 8. Because we are looking at the second electron shell, which can contain up to a maximum of 8 electrons. So carbon currently has 4 electrons, and oxygen currently has 6 electrons. So for carbon, it needs 4 more, and for oxygen, it needs 2 more. So how do I balance this out? So in order to balance it out, I need to have 2 oxygen atoms to share 2 electrons each in order to have 4 electrons needed for carbon, and for oxygen itself, it also have the same number of electron sharing. So this means that I need 1 carbon and 2 oxygen. So now I need to draw out the diagram for a covalent compound. So for carbon, I fill up the 2 electrons inside first. And after that, I need to fill up 4 electrons on the outside. Okay, so you realize that carbon need to share electrons, right? So I draw the sharing. So this one will be oxygen. Oxygen. Okay, so now carbon will share 4 electrons, while for oxygen, it will share 2 electrons each. Okay, so let me go back to the chemical formula first. This one will be CO2. So for oxygen, I need to draw in the 2 electrons in the first shell. And write the chemical symbol in the middle to represent that this one is an element of oxygen and carbon respectively. So since oxygen share 2 electrons each, so I should use a dot instead. Because in my legend, I put that oxygen electrons is a dot, while for carbon electrons is a cross. And you need to use different dot and cross, right? For different type of element. Dot, 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 and dot. So now, since oxygen share 2 electrons each, so I draw into the overlap area, 2 electrons each. And now we need to count whether we have all the number of valence electrons needed for each oxygen. So oxygen, right, it has 6 valence electrons, and since sharing is involved, right, that means you should only see 6 electrons that have a dot on each oxygen atoms. So let's count. 1, 2. Oh, there's only 2 currently. So I need to fill in the remaining 4 more. Fill in the remaining 4 more. And when you count, right, you realize that, oh, there are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. All 8 of them are there. So you do the same for the other oxygen. It has 2 electrons already in the outermost shell. Now you need 4 more in the outermost shell. So you draw in 4 more. So this is how you draw your dot and cross diagram for your covalent compound, CO2, carbon dioxide. So there are other dot and cross diagram that you need to consider also. For example, your NH3, CH4, H2O, and yep, so these are some of the covalent compound that you have to learn how to draw. So for example, N2, chlorine 2, Cl2, oxygen 2. Yep. So once you have understood the process on drawing this diagram, you'll be able to apply these same concepts onto other covalent compound. You will work the same way as well. So if you have any questions, to let me know, or let us know, so that we can clarify your doubts, and you'll be learning well when you clarify all your doubts. Okay, thank you.